In this lesson, you'll learn about polylines. More specifically, you'll discover why they're useful and how to create and modify them. You'll learn how to use the Select Similar function, as well as match properties. A polyline is two or more line segments, or two or more arcs, or a combination of lines and arcs. A polyline can be open or closed. Polylines can have segments which overlap or intersect. I'm going to walk you through a project that I'm currently working on. This is a warehouse layout. We're using AutoCAD to help us visualize where we want to locate various work areas, how much space they're going to take up, and where they will be in relation to each other is important, as that affects traffic and workflow. We have areas for staging, shipping and receiving, and spare parts. The first thing I notice is that the text I have here is too big for the spaces. I want to select it and change the text size. A fast and easy way to do that is to use the Select Similar command. I select one of the text elements, right-click, and choose Select Similar. All of the text is now selected. I right-click and choose Properties. I want to change the text height. Right now the text height is at 46. I'm going to change it to 30 and press Enter. Notice that all the text immediately changes. I was able to select all the text elements very quickly and adjust the size using Select Similar and Properties. Next, I want to center the text in each space using the geometric center for each space. I verify that the geometric center snap is enabled on my object snaps on the status bar. I right-click on a text element and choose Properties. I'm checking to see the Justification setting for the selected text. It's justified as top left. I change the text justification to middle center. I should be able to use the grip in the middle of the text to position the text inside the space and use the geometric center to locate it. It doesn't work. I press Escape to release my selection. I need to figure out why it doesn't work. The reason it doesn't work is the space isn't defined using polylines. They're individual lines. AutoCAD displays the element information when I hover over the elements. I have one existing polyline in this drawing right now, and that is for the lower staging area. In order for me to center the text properly, I need to set up each of these spaces as a polyline. I'm going to change my layer to border to make it easy for you to see what I'm doing. There are two ways for me to create polylines. I could use the Polyline Edit command and convert the existing lines to polylines, or I could trace over the existing lines to create a new polyline. I'm going to demonstrate both methods so you can see how the different commands are used. I enable Ortho on the status bar. This ensures that any line segments I draw will be straight. I'm going to start by placing a polyline for the RMA area. I'm going to select the polyline from the Draw menu on the Home ribbon. I'm going to select a start point and right-click and select the width option. I'm going to set my starting width for 10 and my ending width for 10 to make it easier to see the border. And then I'm just going to move my cursor around the space and use the existing endpoints to help me create a new polyline. I right-click and select Close to complete the polyline. For the spare area, I'm going to create another polyline, but I'm going to add an arc to the left side. Polylines can be composed of both arc and line segments. I right-click and select Repeat Polyline. The polyline retains the last width value I entered, so I don't need to reset it. When I get to the point where I want to place an arc, I right-click and select Arc to switch to arc mode. Once I have selected the 2 points that define my arc, I right-click and select Line to switch back to line mode. To complete my polyline, I just right-click and select Close to close the polyline. I'm going to create a polyline for the top staging area. I right-click and select Repeat Polyline. I missed the endpoint on the second line, and that made my line segment a little too long. I don't need to start over. Instead, I can right-click and select Undo. This allows me to reselect the point I want and keep going. Then I right-click and select Close. For the shipping and receiving area, I'm going to convert the existing lines to a polyline. I can select the Polyline Edit tool, which is located in the extended area of the Modify panel, or I can just type the shortcut PE for Polyline Edit. I type PE for Polyline Edit and select one of the lines for the shipping and receiving area. I am asked if I want to convert the line to a polyline, and I press Enter to accept the Yes option. I then right-click and select Join to add the additional lines to the polyline object. I need to change the width to 10, so I right-click and select Width and change the width value to 10. I then press Enter to exit the command. Now when I hover over the rectangle, AutoCAD displays that the element is a polyline. First, I need to verify that the justification for all of the text is correct. I'm going to select one of the text elements. I right-click and choose Select Similar. Once again, I've got all the text selected. Then I right-click, choose Properties, and change my justification to Middle Center. I'm going to press Escape, and that releases my selection. Notice now when I select a text object, my grip is right in the center of that text. I make that center grip hot and then hover over the border of my polyline to activate the geometric center and reposition the text. It locates the text nicely right inside of the polyline. I'll repeat that for each of the text elements. All I have to do is use the grips and object snap to reposition each text element. You may recall I wasn't able to use the geometric center when the rectangles were defined by individual lines. The lower staging area was already a polyline. I want to change the width of that polyline so it matches all the other polylines I just created. I could use the Polyline Edit command and just modify the width, or I could use the Match Properties tool on the Home ribbon. I select the Match Properties tool. I select the polyline for the shipping and receiving area as my source object. I right-click and choose Settings. Notice in the lower half of the setting dialog, Polyline is enabled. That means that I can match any special properties of existing polylines, like width. I press OK. I select the lower staging polyline, and it automatically updates. My manager wants to know how much square footage these spaces are taking up. There are a lot of different methods I could use to figure it out, but I have found that the boundary command works really well for this. I'm going to switch to the boundary layer. I'm going to draw a rectangle around my warehouse layout. When I hover over the rectangle I just placed, AutoCAD reports the object as a polyline. That's a good thing to know. Rectangles are polylines. I type boundary. The boundary command allows me to create a polyline or a region. I select a polyline to be created. I pick a point inside the rectangle but outside the warehouse layout. A polyline was created. I'm going to select it and move it outside the rectangle so you can see it. Notice it's an outline of the warehouse. Before I look for the square footage, I'm going to use the status bar to change my units to architectural. I select the polyline, I right-click and select Properties. I look in the area field, and now I have an answer for my manager, 6,005 square feet. We've reviewed different methods to create and modify polylines. We used Polyline Edit to convert lines to polylines. We used match properties to ensure that our polylines use the same width. And we used the boundary command to create a polyline outline of our area.
To create an arc, you can specify combinations of center, endpoint, start point, radius, angle, chord length, and directional values. Arcs are drawn in a counterclockwise direction by default. To switch the direction of an arc, you can also hold down the Control key as you drag in a clockwise direction. There's so many options to create arcs, and many users can get overwhelmed with that. This lesson will cover just a few of the methods to create and modify arcs. We have a drawing with several different design options. I'm going to place my first arc using the Start End Radius option, and I'm going to use this door design option right here. So I go up to the Draw panel and I select the arc here and I select Start End Radius. Now you can see there's lots of different options available. You want this one here, Start End Radius. And if you hover over them, you'll see that a lot of the time in AutoCAD it gives you a little description of what each particular arc option gives you as well, which is very useful. So I'm going to select Start End Radius like so. Now I need to specify the start point of my arc. Now remember they go counterclockwise. So I'm going to use a midpoint snap there to an endpoint snap there, and then it prompts me for the radius of the arc. You'll notice down on the command line I can also hold down Control to switch the direction, as I mentioned earlier. So what I can do now is type in 900. It's a 900mm door opening, and press enter to confirm, and there's my arc in place in that particular door opening. Now I can also offset an arc as well, which is very useful, and I'm going to show you one of the advanced tools in the offset command as well. We're going to utilize this door design option here. So I'm going to go to the offset command here, like so. There's offset, and that's on the modify panel on the ribbon. And I'm going to use the through option there, like so. So specify offset distance or through. But before I do that, I'm going to right click and use the erase setting, and what that will allow me to do is erase the source object after offsetting. I'm going to select yes there, like so. Then it takes me back to specify offset distance or through. So I'm going to press enter to accept the through option in the offset command. The object I want to offset is this arc here, like so, and I'm going to go through the midpoint there on the door opening. And as you can see, it's offset the door beautifully, and it's erased the original door object. I'll press enter to finish there, and then all I've got to do is click on this line here and utilize this grip here and take it up to the endpoint snap, hit escape to deselect, and I've updated my door using the offset command and the arc of the original door size. My next arcs will be created using the Start End Angle method. I'm creating some double doors over here like so. So again, Draw panel and click on the flyout, and we're going to select, as I said, Start End Angle. So I select Start End Angle like so. Utilizing my object snaps, I'm going to hit the center snap there, click there, and come up to the end point here like so. And then I need to specify my included angle. Now you'll notice you can also, if you want to, use object snap tracking like so and polar tracking to do that. My angle that I want to specify though is 90 degrees. I type it in, press enter, and there's my 90-degree angle. Now the way that I drew that particular arc, I started at the small circle down here and moved up to the end point here. That's counterclockwise. What happens if I do that on the other part of the double door? Let's go back to my Start End Angle here, like so. Start End Angle on the flyout. And I'm going to start on the center here, left click, and to the end here on the end point, and again left click. Now this time, if I just typed in 90 degrees, I'd get a weird arc like that. I need to type in minus 90 degrees to confirm to AutoCAD that I'm not going counterclockwise. I'm going clockwise because it's a negative 90 degrees. I press enter to confirm, and there's my arc in place in my double doors like so. What I'm going to do now as well is place one of my arcs with my favourite method of placing an arc, and that's in this door option just here, like so. So we're going to utilise start end direction. So let's go here to start end direction, again using the flyout, and I'm going to start here, start and end, using my object snaps and then direction. Now the benefit I've got here, look, I can just move out, and as I come out you'll notice that my object snap and my object snap tracking and my polar tracking are all helping me quite dramatically here. I can just move out any direction I want to. But if I utilise the polar tracking and the object snap tracking and just click, there's my 90-degree angle in place, just specifying the direction of my arc in this particular case. One of the other things you can do with arcs is utilise the lengthen tool. I'm just going to pan across slightly, and as you can see here I've got an arc that isn't finished forming part of a wall. What I can do there is use dynamic lengthen to lengthen that arc. If I go to the modify flyout here and just pin this open, you'll see that we have various commands available. One of them here is lengthen. So I'm going to click on lengthen in the modify panel and come out here. I'm going to right click and select dynamic. Now dynamic allows me to dynamically lengthen the object. So if I click on this end of my arc here and just drag upwards until I get to the object snap there, which is an endpoint, and left click, I've dynamically lengthened my arc utilizing the object snap and the dynamic lengthen feature in AutoCAD. I'll just press enter there to finish. So as you can see, various different methods to work with arcs, and also there's offset and lengthen in there as well. In this video I've demonstrated some of the methods you can use to create and modify your arcs. I encourage you to take some time out to explore each method and try it out in AutoCAD. You might find a new favourite option to add to your AutoCAD workflow.
We're going to be talking about how to create and modify polygons. The Polygon tool is quite useful because it allows you to create a shape consisting of more than one line with just a few mouse clicks and data entries. I'm going to be editing my polygon using the Chamfer tool. I'm going to be using some of the more advanced options for Chamfer, like no trim. The no trim mode allows me to place the chamfer, an angled line, without deleting or trimming any of the existing elements. I have some hex bolts which need to be defined as polygons using the edge option. If I hover my mouse over the hex bolt feature, you see that each hex bolt is defined using lines. This is pretty poor practice because it wouldn't take much to select one or more lines and then move them out of position. Or if I wanted to delete a bolt, I have to make sure I select all the lines. If I need to move the bolt, I have to make sure I select all the lines. So having the bolt head defined as separate lines can get pretty tedious pretty fast. I could use the pedit command to join the lines, and that would create a polygon to represent the hex bolt. This would be converting those lines into a polyline. But I want to demonstrate the polygon command, so that's what I'm going to use. I can use the Polygon Edge command to create these hex bolt heads pretty quickly. The Polygon tool is located on the Draw panel on the Home ribbon. It is hidden in the drop-down under the Rectangle tool. I select the Polygon tool. I set the number of sides to 6. Then I press Enter. I right-click to select the Edge option. That uses an edge as the option to place and define the polygon size. Then I select the 2 endpoints of the line on the right side to place the polygon. Notice I select the bottom endpoint first and then the top endpoint. The order I select the endpoints and which endpoints I select determine the orientation of the polygon. The polygon is placed and defined using a counterclockwise method. When I hover over the polygon, AutoCAD identifies the object as a polyline. That's because a polygon is really just a closed polyline. To make the hex head bolt look a little more realistic, I'm going to add a no trim chamfer. You may not be aware of the chamfer tool because it's hidden under the fillet tool on the ribbon, the same way the Polygon tool is hidden under the rectangle tool. I select the chamfer tool from the Modify panel on the home ribbon. I right-click and select Trim and verify that it is set to No Trim. I right-click again to set the distance. I set the distance to 0.04. I press Enter to accept 0.04 for the second value to create a 45-degree chamfer. I then right-click and select Polyline. That means I don't have to select each vertex on my bolt head to place a chamfer. I can place all my chamfers in one shot. The chamfer is placed and my bolt head looks more realistic. To recap, we created a six-sided object using the Polygon tool. We then modified the polygon using the chamfer tool. We explored some of the more advanced options available in these tools, like the edge option in Polygon and the no trim option in Chamfer. I'm going to be using splines to create a topographic map. The spline command creates a smooth curve that passes through or near a set of fit points. By default, fit points coincide with the spline, and control vertices define a control frame. Both methods allow you to adjust the shape and position of the spline. I have two different options when placing a spline. I can create a spline using fit points or control vertices. I have quick properties enabled on my status bar to help me identify and manage my drawing elements. Most of the existing splines in this drawing were created using the control vertices method. I select one of the splines. Notice that the CV frame is currently set to hide. I'm going to change that to show. I close the Quick Properties dialog and zoom into the selected spline. Now you see the control vertices used to designate the shape of the spline. These control vertices aren't plotted, but hiding them can make your drawing easier to read, and you can turn on visibility, like I just did, to make it easy for you to modify your spline. To modify the spline, just select a control vertex and adjust its position. To hide the control vertices, just reselect the spline and switch the CV frame back to hide. Now when I zoom back in, you don't see the control vertices as they are hidden. I'm going to switch to the LT yellow layer on the layer drop-down list located on the ribbon. I'm going to be placing a spline. The Spline tool is located on the extended panel area of the Draw panel on the home ribbon. There are two spline tools available, one to create a spline using fit points, and one to create a spline using the CV method. You can also just type SPL to start the spline command. I type SPL to start the spline command. On the command ribbon, I have three options: method, knots, or object. The current method is set to fit. I can right-click to select method to change my method, or I can left-click on the word method in the command prompt. I am now provided with two choices, fit or CV. I select fit. I can select fit from the right-click method, or press enter to accept as the default. I select some points, then right-click and select Close. I select the spline I just drew. The Quick Properties dialog displays that the spline uses the fit method and the CV frame is set to hide. I change the CV frame to show. So even though I created the spline using the fit method, I still have a CV frame I can use to modify the spline. Or I could select one of the grips available on the spline to adjust the spline shape. If I adjust the spline shape using a grip, the CV frame returns to being hidden. With the spline selected, I right-click and select the Spline menu. I select Show CV Frame, and the frame is displayed again. I select Edit Vertices. I now have the option to add, delete, or move vertices. I select Move. I left-click to adjust the position of the vertex. I can advance to the next vertex by selecting Next, and then adjusting that vertex's new location. I can also use Select Point to select any point on the spline to adjust the spline shape. To exit this mode, I press Exit, type X, or right-click and select Exit. I'm going to switch to the LT cyan layer using the layer drop-down list on the ribbon. Next, I'm going to draw a spline using the CV method. I select the Spline CV tool from the ribbon. Notice as I draw, the CV frame is following my spline. To modify the spline, I need to select it. To add a control vertex, I right-click and select Spline, Add Control Vertex. I then left-click to place the new control point. Splines can have a major impact on your system resources. Because splines are composed of tiny line segments, they require an incredible number of calculations. This can slow down the performance of AutoCAD as well as your workstation. If you're noticing your system slowing down, you can convert your splines to polylines and regain the lost performance. It can be pretty tedious to convert a drawing like this with multiple splines in it to polylines. One way to get around that is to use the pedit command, that is the Polyline edit. Just type PE, right-click to select multiple, and window around or use a crossing to select all the polylines. You are then prompted if you want to convert the elements to polylines. Press Enter to accept. Set a position of 1 to retain any arcs. Now if I hover over the elements, AutoCAD identifies them as polylines. What if I decide that I really wanted them to be splines? I could convert them back by using the undo command, but what if I decide to do a few commands in between that I don't want to lose? For example, what if I wanted to offset this red polyline? I select the Offset tool and then right-click and select the Through option. The Through option allows me to left-click to locate the new polyline. I could have entered in a distance or used an object snap to place the offset line. The Through option gives me, well, options. Now I want to convert that new polyline to a spline. I select the polyline, right-click, and select Polyline Spline. I press Enter. Now when I hover, it displays as a 2D polyline, but there are more grips available for editing. If you want your spline to retain more curves when you convert it into a polyline, use the SPE command along with a high value of 10 or more. You can enter in any value from 1 to 99. The higher the number, the more points are placed and the closer to the spline it will appear. I'll draw another spline using the Fit method. The spline is placed. If I select the spline and hover over one of the grips, you see that I have some multi-grip functions available, including the ability to add a fit point or stretch an existing fit point to reshape my spline. I type SPE. I select the spline, I type 10 for the position, and the spline converts to a polyline. One of the tasks some users want to do with their topo maps is to change the elevations of the polylines. This can be helpful if you need to extract the polyline information or just want to have that information available under Properties. This is another advantage of using polylines over splines. To do this, I will select one of the polylines in my drawing, right-click and select Properties. Notice one of the fields is for elevation. I'll change the elevation value to 10. I then close the Properties dialog. I press Escape to release my selection. You don't really notice the elevation change unless you switch to a 3D view. So I'm going to use the View Cube to switch to a 3D view. That way you can see the elevation change. I'm orbiting around a little using my mouse, so you can see the elevation difference here. To return to a plan view, I type Plan and select the World option to use the WCS. Splines are excellent if you want to create smooth curves. You have a lot of options available to help you modify splines, including using the grips and the multi-grip function. You can create splines using fit points or control vertices. And you can switch between the two different controls regardless of how the spline was created. A region is a two-dimensional shape with a unique property. It behaves like a 3D object. You could think of it as a surface. Regions can be edited with Boolean commands like subtract and union, just like 3D shapes and surfaces. Regions can be hatched and have an area property similar to polylines. Unlike polylines, regions also have physical properties such as centroid and moment of inertia. You can determine the value of these properties using the mouse prop command. You can apply materials to regions and use them in renderings. Regions can be extruded into 3D solids, and they can be positioned in 3D space. A region can be used to mask objects that are behind them. Regions are created from any 2D geometry that creates a closed loop but doesn't overlap. We're going to be creating the profile for a spur gear using regions. I have 3 circles and a couple of arcs. I'm going to start by creating a region using the inside of the 2 arcs as my boundary. I'm going to switch to the region layer using the layer drop-down list on the ribbon. I can select the region tool on the draw panel of the ribbon, or I can use the boundary command. I'm going to use both methods in this exercise so you can see how they each work. I type BO for boundary. I set my object type to region. This means I will be creating a region. I choose the Pick tool on the boundary dialog and pick inside the 2 arcs. I press Enter and a region is created. If I hover over the object, AutoCAD displays it as a region. Notice that the region was created on the current layer. I'm going to use Polar Array to array the region around the center of the circles. I select the Polar Array tool from the ribbon. I select the region. I press Enter to indicate I am done selecting objects to use for the array. The command prompt asks me to select a center point for the array. I select the center point of the circles. I change the number of items to 12. Notice on the ribbon I can enable the objects to rotate around the circle. If I disable that option, notice how the preview changes. Obviously, I want to rotate the region, so I'm going to re-enable the rotate option. I have associative disabled. Associative groups the elements of the array together so the array can be modified. I'm going to be performing a Boolean operation with these regions, so I'm going to keep them as non-associative. I press the green check on the ribbon to close the array command. I'm going to freeze the region layer to turn off the display of regions to make it easier to create the next region. In order to do that, I'm going to switch back to the spur gear layer and make that layer current. Remember, you can't freeze the current layer. Once I have the spur gear layer as current, I can freeze the region layer. I'm going to delete the two arcs because I don't need them anymore. I want to convert the circles to regions. I select the region tool from the draw panel on the ribbon. I select the circles and press enter. If you look in the command prompt area, you see the three regions were created. When I hover over the circles, they highlight as separate regions. I am going to thaw the region layer using the Thaw All tool on the ribbon. This tool thaws any layers that are frozen. It's a little faster than using the drop-down list. I'm going to make the region layer current. Next, I want to combine the red region group with the yellow region middle circle to create my spur gear. To make it a little faster, I'm going to group all the red regions together into a single group. I right-click and select Quick Select. I set my object type to region, I set the properties to layer, and set the layer to region. This will select any region that is on the layer called region. I press OK. All the red regions will highlight and are selected. I select Group from the Groups panel on the ribbon. An unnamed group has been created. Now if I select any element that is part of the group, all the elements will be selected. If I wanted to name the group, I could use the Group Manager from the ribbon, but this group is not going to be around for very long. It's going to be used in a Boolean operation. I type Union and select the yellow middle region. I select the red region and notice all the red regions are selected because they were made into a group. I press Enter. We now have a new region that's combined from the two selected regions. Notice the new region is on the spur gear layer, even though the region layer is current. This is because the first item we selected for the union was on the spur gear layer. We currently have three regions in our drawing: the outside circle, the combined region, and the small circle. I want to subtract the inner region circle from the combined region. I type subtract. Look at the command prompt. This area is telling me what to do as I walk through the operation. It asks me to select the element to subtract from. It also lists which object types can be used for Boolean operations: solids, surfaces, and regions. I select the combined region as the object to subtract from and press Enter. Now I am prompted for the elements to be subtracted. I select the inner circle region as the element to be subtracted and press Enter. I delete the outer circle. Now I see my spur gear. If I select it, notice it is a single object. If I use the grip to move it, notice that it moves as a single object. If I want to find out the properties of my spur gear, I type Mass Prop and select the region. Mass Prop gives me the option to save the data to a file. I press Enter to select No. I don't need to save that information. Remember, you can always press F2 to expand the command prompt window to review any of that information. The Mass Prop command provides you with the area, centroid, moments of inertia, and more. We used the Region tool to create a spur gear. We also used the commands Polar Array, Group, and Quick Select. In addition, we did some Boolean operations like subtract and union. Boolean operations can be used with regions, solids, and surfaces.
In this video, we're going to learn how to create and work with rays. A ray is a different type of construction geometry. It's different from an X-line in that it only has one endpoint, and the second point goes on to infinity. We'll be placing rays using polar tracking and then using the offset command with some circles. We'll then trim the rays and place them on the correct layer. In this drawing, AutoCAD is being used to design a parachute for fabrication. The ray tool provides an optimal method to lay out the fabric design because rays extend to infinity and a parachute can be quite large and cover a large area. Each parachute design is started with a circle, as you can see here, and we're going to be placing rays using polar tracking. I could place a single ray and then use the polar array tool, but I want to cover how to use the polar tracking tool. How to use the polar array command is covered in a different video. I'm going to come down to the polar tracking tool on the status bar, and that's down here, represented by this small circle. It looks like a slice of pie has been taken out of the circle. I'm going to set my increments there to 15 degrees. As you can see, there's 15, 30, 45, 60. So that has set my polar tracking to increments of 15 degrees. Now the ray tool is in the extended area of the draw panel in the home tab on the ribbon. So let's go up to draw here, expand the draw panel and just pin it open like so. And you can see we've got various commands available. There is xline, construction line. It's the one next door, ray. So we select ray and as you can see it comes out from a point and extends to infinity. I'll click on ray and it asks me for the start point. So what I'm going to do now is select the center point as the start point of my ray. So I'm going to hover there, click on the center snap, and there's my ray coming out from the center of the circle. And I'm going to go around the circle using the polar tracking increments of 15 degrees. So I come out here, click, move up, and can you see each time I got an increment of 15 degrees, I work my way around utilizing the polar tracking as I go. So I'm just going to keep going all the way around the circle. Now this might seem a bit mundane and obviously something like the polar array would cover it, but I want you to get used to using polar tracking here with the 15-degree increment that we've set. So we work our way around. It's beginning to look very much like the sun is shining. It looks like the sun shining, hence ray as in ray of sunshine. And as we work our way round, we get all the way round like so. And you can see now that we're forming the ribs here with the polar tracking for the parachute. When we get all the way around, just make sure that you've got them all covered. It looks like we have, and just press enter to finish like so. If you zoom out slightly now, you'll see that these rays do actually go out to infinity. And what we're going to do now is use offset to offset the circles using the offset command. So offset is on the modify panel. And we're going to leave this layer set to construction. You'll notice the current drafting layer is set to construction. And we're going to utilize a really cool tool in offset where we use the source layer. So I'm going to zoom in slightly again so that we can obviously see our red circle there. And I'm going to go to offset here in the modify panel and come out like so. Now the offset distance that I'm going to set is going to be 6 for 6 inches. But before we do that, do a right click and go to layer, and we want to make sure that we're using the source layer so that anything we offset is staying on the original layer, the red layer that you can see in the drawing. Then we specify the offset distance of 6 like so and press enter. And then we can select the circle and start placing the circles. Now one thing we can do here is obviously just keep clicking with our offset. We could go ad infinitum if we wanted to. Obviously don't go too crazy with the circles, but there's one circle and we come out and we make sure that we come out by that 6. Now you'll notice I've clicked on a ray in error. Be careful, it's very easy to do that with all these rays everywhere. So make sure that when you offset like so, you come out, offset distance is 6, but right click, layer, source, then put your 6 distance in and press enter. But make sure you get a circle and not a ray, otherwise it will start to look very messy. So we come out, we select another one, we come out, and so on. And as you can see, we're utilizing offset now to come out and create our parachute design. And you can see it's starting to look like a parachute now from the top, if you get my meaning. So we'll do a couple more. We don't have to do too many. And we'll go from there and press enter like so. So as you can see now, there's our parachute, and what these yellow construction lines represent is the ribs of the parachute that give it that hemispherical shape when it opens after you've jumped out of the aircraft. So what we're going to look at now is trimming the rays that we've placed. Now these rays go out into infinity at the moment, but we can trim them very quickly and easily. And what we need to do now is we need to make sure that we're going to go up to trim, like so. It's up here on the modify panel. There's trim and extend. Select trim, like so. And then all we want to do now is type F for fence. So we type F for fence and enter. And now we can pick a fence point, like so, going all the way around. And the lovely thing about AutoCAD is it shows you what's going to trim. And in later versions of AutoCAD, you'll find that automatically everything is a cutting edge. You have to specify a cutting edge by right-clicking and going to the shortcut menu if you want a specific cutting edge. But by default, everything is a cutting edge. Once you've done that, press Enter to confirm, and you'll see that all those rays have been trimmed. Press Enter one more time to close out the trim command. Now, what's happened to those rays? Well, they're not rays anymore, they're now lines. If I hover there, you can see it's a line, like so. So if I hover there, can you see that that's on the layer fabric? What we want to do is we want to put these onto a different layer. So we're going to select one of them, like so, right click, and we can use Select Similar on the shortcut menu. So they're now all selected. We're going to put them on the stitch line layer, like so, because there'll be stitches that hold the parachute together, and I'll hit escape to deselect, and all the lines now are on the stitch line layer. And you can now see that you've got a perfectly good parachute in plan ready to be fabricated as well. To recap, we placed some rays to create our parachute using polar tracking. We then offset some of the circles to develop the parachute outline, and we ensured that the offset elements were placed on the correct layer using the layer option of the offset command. We then trimmed back our rays using the fence option in AutoCAD, and we then converted those rays to lines when we trimmed them. We then selected the lines using the Select Similar command and placed them on a different layer to better organize our drawing of our parachute.
We're going to be working in a large structure. I have some hex bolts in my structure. I'm going to use an X-line to help me locate and place my bolts. Since we have multiple bolts, it's easier to define my bolt profile as a block and then insert the block into each location. The X-line will ensure that my blocks remain along the same axis. It's not unusual for many users to work in really large layouts or structures like this one. In order to see any detail at all, we need to zoom in. I want to replace the existing bolt head geometry with a block to better organize my drawing. I go to the Insert ribbon. I select Create Block from the Block Definition panel. The Create Block tool will create a block that is local to this drawing. If I wanted a global block, that would create a file outside of this drawing, and I would use the Right Block tool. I'm going to name the block Hex Bolt and Washer. I need to specify the base point, which is the insertion point for the block. This is a common error many users make. They forget to specify a base point. If you don't specify a base point, your block will automatically use a base point of 0, 0, 0 by default. That means your block will be offset from the insertion point, making it very difficult to use. I select the pick icon and choose the center point of the polygon to define that as my base point. Next, I select the objects I want to be part of my block. I'm going to select the polygon and the outside circle and press Enter. I purposely left out the inside circle so you can see what happens when you accidentally forget an element for your block and need to add it later. Don't worry, we'll be fixing that error. You should see a small preview of your block on the block definition dialog box. The elements I selected are not on layer 0. This means when the block is placed, they will maintain the properties of the layer they are currently on. I have selected Convert to Block, which means the selected elements will automatically be converted to a block. Then I press OK. Now when I hover over the polygon, AutoCAD displays it as a block reference. I realize that my block is incorrect and I need to add in that missing circle. I also want to move some of those elements to the correct layer. I select the block, right-click, and select Edit Block in Place. I want to enable the default, which allows me to select all nested objects. This means if I have a block inserted into a block, or dimensions or attributes, I would be allowed to select those as well. I press OK on the ribbon. I select Add to Working Set. Notice that anything that is not part of the block is grayed out. That helps you identify what's part of the block definition and what isn't. I select the inside circle to add it to the block. See how the circle is no longer grayed out? Because it's now part of the block definition. Next, I'm going to reassign the two circles, which represent the washer, to the hex head layer. I select the circles and select the layer from the drop-down list. Then I right-click and select Close. This saves the changes to my block. I press OK. Now when I hover over the block, the two circles in the polygon will highlight because they are part of that block. This is another advantage of using blocks. If you make a change to a block and you have several instances of that block in your drawing, they will automatically update once you save the changes. I want to copy and place this block along my structure. I want to ensure that the block stays aligned on the same axis. Because my structure is so long, an xline is a useful tool to ensure that my blocks are placed correctly and remain aligned. I'm going to switch to the construction layer. I'm going to select the xline tool from the extended lower part of the Draw panel on the Home ribbon. Notice in the flyout, the xline is called Construction Line. The xline tool is useful because it doesn't have any endpoints. It goes to infinity in both directions. I select the xline tool. I right-click and select HOR for horizontal to place a horizontal line. Then I select the center point of my hex bolt to place the xline. I right-click to end the command. When I zoom out, you can see that my xline extends across the entire drawing. Remember, an xline is infinite in both directions. I'm going to zoom back into the area where I want to work. I'm going to switch to the hex bolt head layer. I select my hex bolt block. By combining all those elements into a block, it now has a single grip, the insertion point. I can copy or move the block using that single grip. I activate the center grip, right-click, and select Copy. Then I move down my structure to place my copies. I'm using the xline to ensure that my bolts remain aligned. When I get to this bolt, I immediately see an error. The xline shows me that the existing drawing had bolts placed out of alignment. To recap, I created a local block. I then modified the block by adding some elements and reassigning layers. I then placed an xline to help me locate additional bolts. I use the hot grip on the block to place multiple copies to different locations. The X-line was useful because it ensured that any bolts I placed were located correctly in my structure. Multilines are objects that can consist of up to 16 parallel lines. The individual lines in a multiline are called elements. Multilines behave similarly to polylines. Several connected multiline segments form a single object. Multilines are created using the mline command, and they are edited using the mledit command. You can justify multilines to control how multilines are placed. The best real-world application I know for using multilines is when creating street maps. To help me design my map, I'm going to attach an image of a small map as an underlay. To start, I select the Insert ribbon. I select the Attach tool on the Reference panel on the ribbon. I switch my files of type selection to image files. I select Map 1 and press Open. I disable the insertion point, scale, and rotation options. This means that I will be accepting all the defaults. The map will insert using a 1:1 scale, it will not be rotated, and it will insert at 0, 0. I press OK. I zoom extents by double-clicking on my mouse wheel. I also want to fade the image a little to make it easier for me to see my AutoCAD elements. I select the image. On the ribbon, I adjust the fade value to 58. I want to rotate my UCS so that my X and Y axes align with my map. To rotate my UCS, I select my 3D Tools ribbon. I select the Rotate UCS about the Z-axis tool. I select a point aligned with one of the streets. The UCS is now oriented, so it is aligned with the map. Next, I need to scale the image so it is 1:1. I use the Measure tool on the Utilities panel on the Home ribbon. I select Distance and select 2 endpoints for the road named Asbury. I get a distance. The residential street width is 28 feet, or 336 inches. I can use AutoCAD's calculator tool to determine how much scale I need. I can even use that tool inside a command. I select the Scale tool from the ribbon. I select the image underlay. I select the base point. I'm prompted for the scale factor. I type 'CAL to indicate that I want to use a calculation. I'm prompted for an expression. I type 336 divided by the number I got when I measured the street. Now when I remeasure Asbury's street width, I should get a number close to 336. It's time for me to start placing roads. In order to do that, I need to define a multiline style. I want to define 2 multiline styles, one for the residential areas and one for the busier 2-lane road. To define a multiline style, I type ML-style. I select the New button. I name my first style Single Lane. Notice that your multiline style cannot have any spaces or strange characters in the name. I press Continue. I need to define the lines used for the style. My first line will be offset 168 inches from the center. I want it to be color white and the line type continuous. I select the Add button to add a center line. I set the offset for the center line to be 0. I set the color to be yellow and the line type to be center 2. I modify the third line to be offset minus 168 inches from the center. I set it to be color white and the line type continuous. I press OK. You see a preview of the new multiline style in the preview window at the bottom of the dialog box. I'm going to define my next multiline style. I select the New button. I name my second multiline style 2-lane. I press Continue. I select the Add button to add 2 additional lines. I modify the lines so that the first line is offset 273 inches from the center. I change the color to white and the line type to continuous. My second line is offset 136.5 inches from the center. I set the color to white and the line type to -2. I set the offset for the center line to be 0. I set the color to be yellow and the line type to be center 2. I modify the third line to be offset -136.5 inches from the center. I set it to be color white and the line type -2. The last line is offset -273 inches. The color is set to white and the line type is set to continuous. I press OK. You see a preview of this multiline style. The current ML style is set to standard. I highlight the 2-lane multiline style and select Set Current. The dialog box updates to display the 2-lane style as the current ML style. I press OK. We're going to look at placing the multilines in the roads layer in the next video.
I want to place my multilines on the roads layer, so make sure you're in the Home tab on the ribbon, Layers panel, click on the layer drop down and select Roads as our current drafting layer. Then we're going to start with the multiline command, so we can type ML for multiline like that, and you can see it pop up on the suggestion menu on the dynamic input. Press enter to confirm that, and then we need to check which multiline style we want to use. So it's a right click and select Style. Now, if you don't remember your multiline style names, just type question mark and enter. And you'll see they pop up on the extended command line at the bottom of the screen there. So we've got single lane, standard and 2-lane. I want 2-lane, so I type in 2-lane as my multiline style and press enter to confirm. I can then minimize the command line by clicking on this arrow here, like so. Now, I also need a justification, so it's a right click, justification on the shortcut menu and top. Now, I'm not going to click exactly to the PDF underlay here with the street map. I'm just going to do this as an indicative map using my multilines. So I'm just going to click approximately on the intersection, take the multiline up to here and click again. I'm just going to take it up to the bigger interchange here and just angle that slightly and click again and enter to finish. There's my first multiline indicating a busier road on the street map. So what we'll do now is we'll right click and we'll repeat multiline, and I'm going to right click again and go back to style, and again question mark in case you've forgotten and press enter. And we've got the other single lane is actually single lane or one word, so I'll type that in like so, press enter to confirm and come down to the arrow to minimize the command line. So now we're going to specify the start point of the single lane multiline. So I'm going to start here. I'm just going to take this up and around and form a square like that. And we'll take it down to there and we'll snap to there like so, and then enter to confirm. So there's our single lane multiline. I'm going to place some more single lane multilines. So it's a right click and repeat multiline again. And I'm going to come off of this point here and take one down to here like so. And again, enter to confirm. Now you can see that one there hasn't joined. It's snapped slightly away from that particular multiline. Don't worry about that. We'll use multiline edit in a minute to fix that. Right click, repeat multiline, and I'm going to do one more just here. I'm going to come off of there and again come across to there like so. And you'll see that's kind of gone to the middle. I'll press enter to finish like so. Now, what we need to think about here is cleaning up some of these intersections. They're not perfect, as you can see, but you can select a multiline and select a grip. And as you can see, I can move that over and just hit escape a couple of times using the grip if you want to. You can also, however, use the extend tool, which is really useful. So on the modify panel now, if I go up to the extend flyout here and select extend, in later versions of AutoCAD, the extend and the trim command automatically use everything as cutting edges or boundaries. So we're extending, so our boundary edges are everything that's in the drawing, all the entities that are in the drawing. If I want a particular boundary edge, I could right click and select one, but I don't need to in this case. So I'm going to select an object to extend. So if I hover here, click on the end of this multiline, and then go merged, can you see it merges it and joins it together? If I go here and click there and go merged, it's merging that one for me as well. So I'll do the same again. I'll go to this end. That's merging nicely, like so. And last but not least, come to this one here and merge it. And it'll merge that, and it'll extend it across as well, which is fantastic if we need that. We don't in this case, but I'm not going to worry too much. It's a very indicative roadmap. I'll press Enter to finish. Now I can edit crossed intersections really quickly and easily. We've got a crossed intersection here that looks somewhat untidy. So I can use mledit, the multiline edit command. So type mledit and enter, and it will give you the multiline edit tools available. Now the one that I want is a merged cross, this one here, because everything then merges together. Can you see where the dashed lines merge across? So I want a merged cross, and I simply select that one and that one. And can you see it merges it beautifully so that the lines cross nice and neatly? I'll just press enter to confirm that. Now we have one more down here where we need to merge this line with this line. Let's see how that works. So we type mledit like so. And we've got the opportunity there to have a corner joint. So let's do a corner joint of this multiline and this multiline. And as you can see, it joins it nicely at the intersection there on the street map, so to speak. So I'll press enter to finish. Now, one of the things I'm not seeing here at the moment is the dashed or center lines that were applied in my multiline styles. So to see them, I need to adjust the line type scale on my multilines. It's very quick and easy to do. We'll select a multiline, doesn't matter which one, and then we'll right click and we'll utilize select similar. Selects all of our multilines like so. So what I can do now is do a right click and bring up the properties palette. And we need to change our line type scale. So our line type scale there is 1 at the moment. I'm going to change that to 100 and press enter. And then what we'll do is we'll close the properties palette like so and hit escape to deselect. If we zoom in now, you'll see that we can see all of our nice dashed lines as they should look on our street map. Now obviously we need to zoom in a little bit to see those, to get in a bit closer, but you can see that our multi-line styles have all our center lines and dashed lines, and when we start tidying this street map up, you can see how neat and tidy it will become, and more importantly it's more representative of the roads on the street map because our multi-line styles represent them. In these two videos, part 1 and part 2, we reviewed some techniques to use when creating and modifying multi-lines. We attached an image as an underlay to help place the multi-lines and adjusted the image appearance using the fade control on the ribbon. We also created some multi-line styles using different colors and line types and then added them to the drawing. We used the extend tool and the mledit command to modify the multi-lines. We also modified the multi-line properties by adjusting the line type scale used by the multi-lines. Maybe check out how multi-lines can help you in your AutoCAD workflow as you move forward.
We're going to be learning about how to create 2D isometric views for drawings. You're going to learn how to switch between isoplanes. We use isoplanes to create the different sides of our isometric view, and we use ellipses to create isocircles that represent the holes in our isometric view. And we'll be modifying our dimensions on our isometric views so that they align with the isoplanes. Using isoplanes and the isometric tools is one of the easiest ways to create a 3D representation without actually having to move into 3D. Isodraft allows the user to place elements on isometric planes. You can use Ctrl-E or F5 to cycle through the isoplanes. There are 3 isoplanes, left, top, and right. We use the ellipse tool with the isocircle option to place circles on isoplanes. We use the oblique tool to change the oblique angle of the dimension using plus or minus 30 degrees. If you're on the left isoplane, use plus 30 degrees, and if you're on the right isoplane, use minus 30 degrees. I have a 2D drawing using third angle projection with the top, front, and right side views. I want to add a 2D isometric view. I have some layers already defined with a layer for the object, layers for hidden and center lines, and a dimension layer that we'll be using later. I'm going to have my polar tracking on. I have polar tracking set to the 30, 60, 90, 120 degree angles. I'm going to turn on Isodraft. You'll notice Isodraft lets you toggle between isoplane left, isoplane top, and isoplane right. I'm going to use isoplane left to start. I select the line tool from the ribbon and start my line here. I look for the 150 degree angle and type in 100. I move my cursor straight up and type in 60. I move my cursor forward, looking for the angle of 30 degrees, and type in 25. I shift my cursor down and type in 50. I move my cursor toward the front, and I use the end point of the start of my line to help me close the left face. I'm going to switch to the right isoplane, and then I'm going to go back to the line command to draw my right face. I'll go to a 30 degree angle again and type in 50. I go up and type 10, and then come back and use the endpoint to complete that face. I repeat the line command, go over 10 at a 30 degree angle, go down 12, go over 30, go up 12, go over 10, come down 50, and then use the endpoint to complete that face. To complete my view, I want to switch to the top isoplane. This time, instead of using the status bar, I'm going to press Ctrl E to cycle through my isoplanes until I get to the top isoplane. I use the endpoints of my existing lines to help me place my remaining faces, as well as entering in the correct dimensions. I'm going to flip to the left isoplane for this remaining line using Ctrl E. And then I go back to the line, I come down 12 units, and then again use my endpoints to help me place that face. I use Ctrl E to flip back to place the final line. Next, I'm going to be placing an isocircle on the top face using the ellipse tool. In order to do that, we want to locate the center of the circle 40 units and midway from the edge. It can be helpful to draw a construction line to help you locate the center point of an isocircle. I like to verify that the construction line is located correctly by using the Quick Measure tool. I select the Quick Measure tool from the ribbon and verify that I have the correct measurement. I'm going to place my hole using an isocircle. I select the ellipse tool from the draw panel on the ribbon. I want to use the axis end option for drawing an ellipse. AutoCAD prompts me if I want to place an arc using arc, center, or isocircle. I'm going to select the isocircle option. I select the endpoint of the construction line to locate the center of the isocircle. AutoCAD then prompts me for the radius or diameter of the isocircle. I select the diameter option. I want an isocircle with a diameter of 25 millimeters, so I enter that value, and my isocircle is placed. I want to add the bottom face of this hole. To help place that isocircle, I'm going to move the construction line to the midpoint of the bottom edge using the grips. I right-click for recent commands and select the ellipse command. and right-click to select Isocircle. I select the center point using the endpoint of the construction line. I select the diameter option. I set my diameter to 25 units. I'm going to delete the construction line that I used to help place my isocircles. I'm going to trim out the bottom isocircle. I select the Trim tool from the Modify panel on the ribbon. I press Enter to select everything in the drawing as a cutting edge, then select the section of isocircle to be deleted. I'm going to be adding dimensions to my 2D isometric view. Since I'm going to be placing dimensions, I'm going to switch to the Annotate tab on the ribbon. I'm still on the isoplane top. I can see that from the status bar and also from the way my cursor is oriented. I'm going to select the Align Dimension tool from the ribbon. I'll select one endpoint and then another endpoint and place the dimension. I'm going to use the Oblique tool from the ribbon. Since I'm going to use this tool quite a bit, I'm going to pin the panel open so the panel remains extended. I select the Oblique tool, select the dimension, and set the angle to 30, and the dimension will clean up so that it looks quite proper. I'm going to place another dimension. I select the Oblique tool, I select the dimension, and I enter 30. It doesn't work. Remember I said use a positive 30-degree angle for the left view and a negative 30-degree angle for the right view. Since I'm placing the dimension on the right isoplane, I need to use a negative 30-degree angle. I select the Oblique tool, select the dimension, and I enter -30, and the dimension cleans up. You've learned how to create 2D isometric views for drawings using the isoplanes, learning how to use the shortcut keys to switch from one isoplane to another, using the polar tracking to help you stay in an isoplane, and using the isocircle option for the ellipse to place isocircles.